Hello, so this is my implementation of a binary classification model using keras and pytorch. And for the sake of time, I already went ahead and ran all the cells. So if we come down here and we train the model, it'll show us the epochs that it goes through and it'll print out the loss and the accuracy of each epoch. So for the implementation of my chatbot to make it a little faster, I went ahead and implemented model checkpoints so that way the output of my model would be saved into a file without having to retrain the model. But throughout training, you can see that every time that the accuracy of the epoch improves, it'll print out what the accuracy improved from and what it improved to, and it will save that model the to the model checkpoint file. And in the case that it does not improve, it will say that it does not improve, and it will keep the previous checkpoint uh, that was saved into the model checkpoint file. So after the epochs run and it concludes with a final value, we can come down here and print the results, and it'll show us the accuracy and the loss of the best model. And this cell can be clicked. So if you want to load the um, previous values, previous values of the model, you can click on this without having to retrain the model, and you will get these values once again. And down here, I implemented a plot so you can see a visualization of the accuracy and the loss across the epochs. So this similar implementation was also done with PyTorch. The implementation was just about the same. Um, so if we come down here, we can see the print statement from all my cells that I ran, and it'll print us the accuracy and the loss from that model. And I also implemented a model checkpoint in this implementation. That way, you wouldn't have to run the training again to retrieve the values. And additionally, just like keras, I implemented a visualization of the data of accuracy and loss across the epochs. So moving on to my chatbot, it is a rule-based chatbot that I implemented. So if we run this and we come down here, we can do simple chit chat like up here we can say hi, and it will give us a response. My apologies, I realized you couldn't see the query box up here. So if we go back and run the chit chat model, like before, we could say hi and it'll print us a statement. But for the functionality, you can type, "Can you perform binary classification for me?" And then it'll ask you what library you'd like to use for the classification. So first, we'll just say keras. And then up here, it'll ask us the path to the directory with the train and test data. So I'm going to go ahead and copy the path for this. Go ahead and paste it in there and then hit enter. And then it'll give it 1 second to run and it will print the accuracy and the loss. Okay, so right here it'll show us the accuracy and the loss of the last save checkpoints models. This is especially a good way to find the accuracy and loss since we don't have to retrain the model. It doesn't take as much time. Uh, Therefore, rendering down the amount of time that the chatbot takes for this. So if we want to run this again so we can use the PyTorch model, we can ask the chatbot, "Can you perform binary classification for me?" again. And it'll ask us which library we'd like to use. So this time we'd like to say PyTorch. And then it'll ask us for the directory once again. Since I already have it copied, I can go ahead and paste it in there again and hit enter and give it a second again to run the PyTorch model. So right here we can see that the chatbot does indeed print out the accuracy and loss of the PyTorch model. In my results.txt, you can find the results from 4 runs that I did and then the average accuracy and runtime for your keras. and then the runtime and accuracy for whenever before I optimize the PyTorch model, and then after I optimize the PyTorch model. To test the uh, model versus another LLM, what I did was, since I had to individually enter each image into Google Bard, I took the first 10 images from my data set. So in my test data set, I went into the defective and non-defective and took the first 10 images, and I pasted them into a new data set. So here they are right here. And what I simply did was go up to my model and then change the test directory to this directory, so it would only test on the 20 images in total that I have, and get the results from them. And after you run the notebook again, at the bottom you should get an accuracy of 100%, which I got for both of my keras and my PyTorch model.